Hi, my name is Josef, Dr. Josef, and I'll be teaching ENPM604, Machine Learning Applied to Cyber. There have been lots of cyber events since COVID, including shutting down pipelines, increases in identity theft, increases in corporate and government attacks, and it's been at an unprecedented level since the start of COVID. The objective in this course is to take some of the advanced knowledge and learn the advanced knowledge of machine learning as applied to cyber and turn each one of you into an expert in a niche topic area. Part of this is because of the fact that the latest state-of-the-art antiviruses, yes, have started using machine learning for the past few years, but we need to take it a step further to be able to manage a lot of the things going on. So we need to develop new and unique expertise here. The end goal is you can pick any topic towards the end of the course of Cyber ML, provided it's current, latest, and or state-of-the-art. So the prerequisite for some of this, to better understand it, is some knowledge of Python and certain coding skills, basic coding skills I think would be good, and ones where you can understand if you need to do forensics on software itself. Okay, the material covered in the course is logistic regression and linear regressions, support vector machines both from the historical value of the SVMs to more advanced and current approaches on it. We'll also do similarity analysis as a tool, cluster algorithms, unbalanced data sets, as well as looking at some of the tools or libraries that exist for that, such as the PyOD, which is for outlier detection, has some 20-some algorithms in there that you can use for this, as well as other algorithms. And we'll also look at neural nets from the early stage as a background for historical purposes to the latest. And this is going to include things like recurrent neural nets, their advanced versions such as the LSTM, gated recurrent units, GRUs, and things along those lines, as well as a similar family of algorithm that has been used the latest in the physical world to forecast climate change, and that is the reservoir computing. We're also going to include graph neural nets, their applications, limitations, attention neural nets, which you probably know by their popular name of transformers, and a brief look at large language models such as ChatGPT. Finally, we're going to also look at creating cyber resiliency for using heterogeneous machine learning models and having an AI reasoner on top of it to keep the models from straying into areas where they misclassify. I'll also bring up some of the types of misclassifications that have been done with machine learning, and therefore ones we want to avoid. There are going to be several labs in Python to solve on your own. There's 2 midterms, and then there will be no final exam. Actually, the midterms, we'll call them semester tests. That sounds better. Instead of a final exam, what you're going to be doing is writing a paper on your topic of choice during the semester and giving a short presentation. The reason for the presentation is to let your fellow students learn about your area of expertise, and perhaps during future collaboration, there might be something that ensues, such as, business opportunities or something like that after the course. So we're going to be covering quite a bit in the course. We're going to do it from more of a higher level because it's impossible to really cover it in detail. But I will make sure that you don't learn too many things. You can't have too much knowledge on certain things, because if you do, I'm going to have to use the neuralizer on you and delete that knowledge.